solving equations by graphing on a calculator. Now, if you look at the kind of equations we're solving, they're like pretty complicated equations. I'm going to show you a super easy one just to start, because you already know the answer for this one, I hope. X plus 5 equals 7. Could you solve that by hand? I'm going to show you how to do it on the calculator so you understand what we're doing today. So take out your calculator, go to y equals, and this would be a really good skill to know, especially if you take an ACT class, or not class, I mean a test, because this is perhaps going to save you some time. Now, I would never do it for this because I can do that way faster in my head than I could do it on here. But like for some of these are pretty complicated, this would be faster. So what I'm going to do is I'm going to change this into a system of equations where y1 is going to be x plus 5 and y2 is going to be 7. So I'm changing it into a system. And when I change it into a system, we know that the y1 and y2 should be equal. That's why x plus 5 equals 7, because these two have to be equal too. So I'm going to do x plus 5. No, is it x plus 5? Yeah, it's x plus 5. And then 7 as my two equations. So you're just taking the two sides and you're making them equations. Then we're going to graph it. There's x plus 5. And there's 7. Okay. Now what I'm going to do is I'm going to find my intersection button to find where they actually cross on the calculator. So this is a new calculator skill for you. Trace is where all our fun stuff is. And number 5 is where they intersect. So we're going to click number 5. And it asks first curve. That means, now this is a straight line, but it just calls it a curve because maybe I have a curve in there. What? Yeah. So you just have to, okay, we could have 10 graphs on here. We could on here. You need to tell the calculator which graph you want to find the intersection between. So I want to find the intersection between my blue graph, and it is on the blue graph, so I'm going to hit enter. And then I want to find it between the red graph. So it is on the red graph. I'm going to hit enter. And then guess. I'm going to go close to what? 2? Would you say x equals 2 looks close? Plus that's the answer. So I'm going to choose 2 and I'm going to hit enter. And it tells me where they cross. So the question is, what's the answer to x plus 5 equals 7 though? If we're solving this, am I solving for an ordered pair? My question is, if I'm solving this, am I not what I did down here? If I'm solving just x plus 5 equals 7, what am I actually solving for? I'm only solving for x, so the only answer I need from this is the x value, which is 2. So that was like really simplified of what we're about to do. So let's go ahead and look at question A. And we've got x's on both sides, so we're going to pretend this says y1 equals 3x squared plus 5x minus 1, and y2 is negative x squared plus 2x plus 1, and we're going to type that into our calculator. So get it typed in your calculator, hit graph. How many solutions will we have? Why?
Because it
Because it crosses twice? Okay. So we're going to have, x. When we're done, we'll have x equals, and we'll have a fancy bracket with two different answers in it. Okay? Now you can only find one at a time. So I'm going to hit second trace, and I'm going to do intersect 5. And I want to make sure I'm on the first curve, which is my blue one. If you don't have colors, it should do it in order of the way of when you typed it in, if you don't have the color graphs. So first curve, yes. Second curve, if you can't really tell where it is, you can also use your arrows to move it. Oh yes, I'm now on the red one. And then guess. So I'm going to do the left one first. That looks like it's at -1. So I'm going to type in -1. I don't know if it is. And it's not, but we do have an approximation of where it is. Did you guys get the same answer as me? I can zoom in more if you can't see it. Did you get the same number as me? It's like -1.175391. Okay, so one of our answers, maybe I should have left some more space here. One of our answers is going to be -1.175. Sure. Okay. Yes, why did I? Okay, bring it up. I'll fix it. Okay, come get my charger. And then you could just move up a seat and sit next to the plug. It's, I think, on the floor. It's like it kind of looks like a cell phone charger right there.
Yes.
Yes. Okay, and then the other x that we're going to find, we got to do the same way. So second trace, intersect, first curve, yep. Second curve, yep. Guess. This time I'm guessing around, gosh, 0.5. And it's not at 0.5, but I was close. 0.425. What?
How do you know that?
Okay.
How do you know that you're almost typing graph?
Do you have color? So it should, we only graphed 2,
Right.
so it should pop between them. If you use your arrow, wait, mine's not going to do it right now because I'm on the wrong thing. But like if I move left or right, do you see how I'm moving right now and it's on the blue one? Yeah. And then I'm if I can't tell that I'm on the red one right now, I'll just move over, and now I see, oh yeah, it is on that one.
Okay.
So if it's like, because last time it used like the last place we were, right? Yeah. But mine, since mine's in color, I can actually, the numbers change colors, so I can actually tell which one I'm on. But if you don't have the color one, it is harder to tell. Okay, so I have 2 answers. Can we move on? We good? See, this stuff easy. We just ran out of time last class. So go to y equals, clear that out. Yeah. y1 equals negative, oh, we also have the other section of notes. Squared plus 2.25, and then y2 equals 2x times x plus 1.5.
Do you want us to write it all each time?
Like this is the only work you have to show of what you
want us, I'm just asking if you want us to write that down each time.
Yeah, so I can see what you typed in. Okay? Because I can't see what's on your calculator. So if you get it wrong, I don't know why, and I don't know what points to give you.
Okay.
I mean, is it possible you wrote the correct thing down and then typed it wrong in your calculator and got the wrong answer? Yeah. So that's why I like being able to see what you think you typed in. See, we got 1 parabola, 2 parabola. It's really hard for me to see where they intersect, although I can tell by the equations. What? It does kind of look like there's only one. If you're not sure, you can use your zoom feature. You hit zoom, and you want to zoom in too, and you can actually zoom in right there. It really does look like there's only one. What? Let's see. Second trace, intersect. So right now I cannot tell what curve I'm on, except for mine's in color, so I can tell that it's on the blue one. But if you cannot tell, just use your arrow, and then you can see which curve it's on. So I'm on the first curve, now I'm on. Oh, there it is. I couldn't see the second one. Second curve, and then guess. We'll guess at 0. And yes, the intersection is at 0, 0. So what is our answer? Right, it's just x equals 0. You don't put the ordered pairs for these because this is solving an equation for x. It's not what we were doing the first day where you find the x and the y. We just kind of approached it the same way as finding the x and the y, but you only write the x as the answer. Do I need to do more examples? Okay, I didn't think we needed to do more. All right, so we also have 3 today. This is the end of chapter 3. This is the end of chapter 3.
So does that mean we have the test next week?
Yep, block day. Block day next week. This is the chapter 3 test on block day.
Oh, come on.
Your body. You can't do calculus. What?
Are we using quadratics the entire year? No. Okay, good.
I'm so. We use like a big thing for algebra 2 is quadratic. Like that's one of the main topics for algebra 2. We use it heavily in 2 and 3 in chapter 4, but we won't be just graphing parabolas in chapter 4. And then in chapter 5, we move on to graphing square roots and cube root. Quadratic 5. But the good thing is we keep doing the same thing over and over again. So what does that do as a learner? Makes it what? More boring? Perhaps. Makes it easier because you're doing the same thing over and over and over again. Like by the 4th time we've done it, should get it, right? Okay, so this is totally a review question. Graph the inequality. So you should have. I'm going to treat it like it's y equals negative 2/3 x, but it is not. But I'm going to treat it that way at first. So how would I graph this line? Yeah, I'm still recording. Go up from where? So what's that called? Y at 0, 4. So I'm going to go to 0, 4 and put a dot. And then what also do I need? What also do I need? Slope, which is negative 2/3. So do not do more than I'm doing right now. Unless you remember how to do this from Algebra 1. Negative 2 over 3. Down to right 3. And I'm off the graph from there, so I'm also going to go up to left 3. Okay, so the first thing is to figure out where the line's going to go, but I'm not drawing the line yet because it is not an equal sign. Okay? So the next thing we have to do is we have to figure out what kind it is. Is it dashed or solid? So why is it dashed? Hannah? Why? It's just less than. Less than equal to would be a solid line. If there's a line under your little inequality, then it is a line. If there's not a line under the inequality, then it is dashed. Because it means that this is kind of going to be like a border for all of the solutions, but it actually isn't a solution. It's not equal to. It is everything less than or equal to. So I'm going to use my handy straight edge that I keep with me everywhere I go.
Did we do this in algebra 4?
Yeah. Well, I don't know when you did it, but it should have been.
I remember.
Yeah, it should have been. And then we have one last thing. We have to test a point. So when you did this in Algebra 1, this is a border where either the stuff above below it gets shaded. So you have to test a point to actually see. Highly recommend you test the easiest point you possibly can, but the point cannot be this long. Give me a point that is not on this line that is super easy to plug in.
2.2.
0, 0, 0 is the easiest one. Now, if it crosses through 0, 0, you can't use it. What we do to test a point, check this point in the equation. We go back to the original equation. 0 less than negative 2/3 times 0 plus 4. And we see if this actually works. Is 0 less than 4? So if it works, 0, 0 is part of the shaded region. So am I going to shade above or below?
Yeah.
Algebra 1. Algebra 1. So let's try one more Algebra 1 example. Y equals 3, or y is greater than or equal to 3x. So we treat it like y equals 3x to begin with. What is my point that I start at, my y-intercept? And then from there, I'm going to move what? Up 3 over 1. I have to determine if it's dashed or solid. Why is it solid? Because it has equal to. So if it has a line, it's going to be a solid line. And then in order to know which side of the line gets shaded, you test a point. Not always. Not always. So that's why I'm teaching it this way, because the answer is not always. Test a point. What point could we plug in to see if it works? Pick zeros. And you can't pick a point on the line. So 1, 1 would be 1, 0 would be great. 0, 1. Negative 1, 0. Like any of them that have zeros, or just 1, 1 is fine. But you just got to pick, and if you want, you can pick 10, 10. It doesn't really matter. Just pick a point that is not on the line. So we're going to pick 1, 1. So Rachel was passionate about that one. And we're going to plug it in. We're going to have 1 greater than equal to 3 times 1. Is 1 greater than or equal to 3? Okay. So that means this point cannot be in the shaded section. That point is below the line. So the shade above the line. Okay? So that's algebra review. Algebra 2, how do we use that now? Algebra 2 is the same stuff, except you're not just graphing lines. That's it. It's going to be the exact same stuff, you're just not graphing lines all the time. Okay? So graphing a quadratic inequality in two variables. So we need to graph y less negative x squared minus 2x minus 1. You can graph this however you want, not calculator. We're going to treat it like it's an equal sign. So methods could I use to graph this one? If I take out the negative 1 and I have squared plus 2x plus 1, does that factor? Does this factor? How? So what am I getting if I'm factoring this? What am I getting? No, I'm not going to do stuff just for satisfaction. I'm going to do it because I need it. What am I trying to find for graphing this? What am I trying to find? Okay, well this wasn't giving me the y-intercept. We can go find the y-intercept. How would I find the y-intercept?
Plug in 0 for x.
Plug in 0 for x. So the y-intercept is at 0, negative 1. Done. What can I find from this? Somebody said it. Yeah, who is that? Oh, it was Riley? Oh, okay. Yeah, you're right. I'm sorry. Somebody else was asking a question and I ignored it because I was trying to figure out who just answered that. If you do have a question, just like maybe raise your hand so I can answer what. Oh, I plugged in 0. Well, like negative 0 squared minus 2 times 0 minus 1. Formula that we talked about when we first learned about y-intercepts with quadratics when it's in standard form, that the y-intercept is the c value.
See, that's what I know. Look, if it's in that form, you don't even got to do no more.
Right. But I always usually talk about the 0 thing because the 0 thing works for every form. The looking at the last number only works for this form. So if you remember it, that's great. And if not, plug in 0. Okay, so to find my x-intercept. No, it does not work for vertex form. This is vertex form. I don't know if you guys realize this is also vertex form. Okay, so our x-intercepts would be, we'd have to solve each factor equal to 0, so it would be like negative 1 equals 0, but that doesn't have any x's, so that gives me nothing. X plus 1 equals 0, so where would my x-intercept be at? So negative 1, 0. And then what about the squared? What does that tell me? No. What's squared tell me? Yeah, but that's not what I meant. Like, we always get 2 solutions when it's squared. We always get 2 solutions when it's squared. So we have x plus 1 equals 0. What is my other factor? Minus 1. What does squared mean? What does squared mean?
It means it's the same thing.
It means it's the exact same answer. So I would have like x plus 1 and I'd have another x plus 1. So why? I wouldn't. So yeah, it's not satisfying to do something I didn't have to do. Okay, so x equals negative 1 is both answers. Therefore, it really is just 1 on the graph. Okay, I still need to find something though to have a good graph here. to be able to reflect points, I still need something. I need the axis of symmetry. How do we find the axis of symmetry? So you could be over 2a with the first one, or you could use this one. You could average the two x-intercepts, or you could treat this one like it's vertex form. It does not matter which way you decide to do it. It does not matter which way you decide to do it, but you should get the same answer no matter what you do. I'm going to average the x-intercepts. So I got x equals -1. That goes right here. So once I have my axis symmetry, then I can find a mirror point for the y intercept. Katie, you look like you're thinking really hard over there.
Right?
It looks like it's not a shrink or stretch.
Yeah, that sounds good. There's a reflection.
Yeah.
So, but I can already tell it's facing down. There's not a shrink or a stretch, but I haven't found my vertex yet. I have, but nobody's told me the vertex yet.
-1.
Yeah. So it's in vertex form, so it would be -1, 0. So yeah, you can just go like your patterns that you've learned for the parent function, because there is not a stretch or shrink. Oop, I didn't mean to do that. Before you connect it, or use pencil, connect it, we have to determine, is it solid or dashed? It's dashed because this does not have a line. So it's a dashed.
Wait, how did you get the last two points? You just
Yeah, I just did like 1, 1, 2, 4, or like that, because it didn't have a stretch, so I knew I could do that. All right, so we graphed it, we figured out what kind of line connects it, and then the final thing we need to do is figure out where it's shaded. So we're going to test a point.
Oh.
What point would be easy to test?
0.
Okay, let's test 0, 0, because that's not on the parabola. That one's easy to plug in. So less than -1. Is that true?
No. Martin, come on.
It's okay, just all right, so that means 0, 0 does not get shaded. So where am I going to shade this? Inside of the parabola.
Wait, could you have like, when you test a point, could you have done like -2? Test it, maybe like 8 points?
2, -2, is that what you said?
No, just like -2.
That was an error.
So -2, 0? Yeah, you could test any point you want,
Okay.
as long as it's not on the parabola, because that won't tell you which side to shade. Okay, and then the last example would be solving a system of quadratic inequalities. So we have a system.
I give up.
Why?
They like that.
All you guys do is whine about how hard it is. If you actually tried, it's not hard.
I mean, I whined the last quarter and not how passionate I am. I just whine.
So you just bring bad energy into my
No,
room
I
for
just
bringing
try to
for
joke.
fun.
No, I just try to joke and make people
Mhm.
Because every test except for one.
So would that be
I got an
Number 1 is going to be dashed. How would I graph y less than -x squared plus 3? What would be the smartest way of graphing this one? What is it in?
Oh,
Oh, it's an, slope, or what's it called? Standard form?
It could be standard form. It is vertex form.
Oh.
Well, vertex form tells me that the vertex is at 0, 3. This is also, vertex form is transformation form. So I could just use transformations to graph this. So I know it starts up at 3, and I also know what about the graph? There's a reflection. Does it have a stretch or shrink? No? Okay. Then I know exactly where to put all those points. A little shortcut there. And then Sophia asked, is it dashed? And I said, yes, it is dashed. Because it is not 2. What I like to do when I have two things happening, well, there's two ways you could do it. I don't like to make the shading super dark. I just might make it really light. Oh gosh, if it's there. I didn't check and test the point. What should we test?
0, 0.
3.
0, 0 is what I'm going to test. You can test whatever you want, but I'm going to test 0, 0. So I get negative. Is that true? Oh, good. Then I shaded the right place. Woo. Okay. But I did that lightly because we have a second one we need to do on top of here, and I didn't want to not be able to see my points. So the second one I have on there is y greater than or equal to squared plus 2x minus 3. We need to find our vertex. How could we find our vertex? Could we put it in vertex form? By what? Complete the square? I'm just reviewing things that we've been doing. You don't have to do complete the square if you don't want to. You could go do negative b over 2a. You could do negative b over 2a to find the vertex, or you could find the x-intercepts by factoring and then average them to find the vertex. There's multiple ways to find the vertex. I'm just trying to review everything. Now what? You're fine. What, Riley?
No, I was just asking, what other way could we do instead of...
Oh, what I was just saying, yeah. Okay, so I'm just going to do this one by complete the square because it looked really easy. The numbers were low. What would I complete the square with?
2x. Are you asking for the answer? Or
Yeah, what goes in here? 1, yeah. Oh, we should be past the point of...
Is it negative 2a squared or is it regular?
It's b divided by 2 squared to get that number.
Oh.
Oops, I forgot to factor it. Oh, I'll factor it next. Sorry, I forgot to factor it, and I'm not using erasable pen. I'll just do it the next step. X plus 1 squared, and then when I move the 4 over, we'll have a minus 4 out there. So where's my vertex? What?
I got a negative 1. Oh, wait. Did you not do the vertex?
I didn't write it yet. What is my vertex?
Is it
Negative 1. It's an ordered pair.
0?
Negative 1, negative 4 is the vertex. That means my axis of symmetry is at x equals negative 1. I didn't write down the axis of symmetry. My vertex is at negative 1, negative 4. Does this one open up or down?
Wait, on the blue parabola, we shade inside the parabola.
It opens up, and is there a stretch or shrink? No, so I can just use my little pattern that I developed because I had to do this so many times.
Wait, if you did the b over 2 squared instead of the other thing, how do you get negative 1? You have to plug it in.
Do you mean negative b over 2a?
Yeah.
If you found that the
Yeah.
axis of symmetry, so whatever number you'd get, you should get negative 1. And then, yeah, you'd have to plug it back in to find negative 4.
If you minus 4, it should have been
Okay, is this dashed or solid, the second one? Solid. And then what point could we check? Test. Okay, let's test 0, 0. So I plug that in, 0 greater than or equal to 0 squared plus 2 times 0 minus 3. So I have 0 greater than or equal to negative 3. Is that true? Whatever Martin says, say the opposite. Just kidding, Martin. All right, so that means I'm going to shade 0, 0 for this graph. So that would be like here. But when we solve a system, the real answer is where do they overlap? Should be where both colors are. So I like to maybe highlight. I don't like to color it in super dark because then you can't see what's under there, but I like to highlight the section that is actually the solution to the system.
Wait, so when there's like nothing,
What, Riley?
when there's like nothing in front of the X, you could just go up by like
1, 1. Yeah.
yeah, okay.
Just makes it a lot faster to try to graph it if you know that pattern. All right, last one. Graph the system of inequalities consisting of y equals negative x squared and y is I'm sorry, I didn't say it right. Y is less than or equal to negative x squared and y is greater than x squared minus 3. This is a really easy one.
The second one
How do I graph y less than or equal to negative x squared? Where's my vertex?
0, 0.
And what do I do from there? And stretch or shrink? Nope. Okay. Is it going to be solid or dashed?
Solid.
What point can I test?
You can test
1, 1? Okay, so I'm going to test 1, 1. That means 1 less than or equal to negative 1 squared, which I have to put the negative on the outside of the squared. So I get 1 less than or equal to negative 1. Is that true? So if it's not true, I have to shade outside of the parabola. No, just kidding. I'm just joking. Oh, gosh, I can't erase this. It is true. It is not true, so I cannot shade. I'm sorry, I forgot what point we tested. Usually I color it in so I don't make that mistake, and I didn't do it. I have to shade inside the parabola. This is where you're supposed to shade, the darker blue. Here, I can do it in a different color. That's where I'm supposed to shade. I apologize. As soon as I started doing it, then I was like, oh no, I'm wrong.
Because it's not true.
Yeah, this can't get shaded because it's not true. So that I have to shade the other side of the parabola. Okay, and what about y is greater than x squared minus 3? Where's my vertex?
0, negative 3.
Okay, there's my vertex, and what do I know about this?
There's no questions, so you can do it right away.
So I can do the pattern.
Yeah.
Yeah. And is it solid or dashed? Okay. Dashed. And what point can I test?
0, 0.
Okay, so I'm going to test 0, 0, which tells me 0 greater than 0 squared minus 3. 0 greater than negative 3. Is that true? Martin?
Yes.
So 0, 0 gets to be graphed. So like I'd shade there, but where do they overlap?
The lower area from 0 to negative 3.
Right in here. That's the part they overlap in.
Wait, are there like times where like they never overlap?
Yeah.
Yeah, you can have that. There would be no solution.
Yeah, exactly.
I have a worksheet for you, and a lot of these I tried to do where you could use transformations, so they're pretty fast to graph. I believe, you're going to have to look through it, I believe I put wrapping a circle on here, which we haven't done, but I have the equation of the circle on your 3-5 notes. It's really easy to graph. The equation of a circle is on your 3-5 notes. No.
Go, Devin. That's what those were.
Wait, what? I don't know why you did
I
that.
put them right there. And then
Because I thought that was. You put them right there. I thought
Man, that was so funny. Come
Trying to
on.
be hilarious, like he's not going to do it for.
Who, me?
Not giving it to him either.
Who, me?
No, not you.
Where do you want me to put this?
So if you look through, before you leave, if you look through, try to find where the circle equations are. So you remember, I told you there's going to be some circles on here. We did circles on section 3.5 on block day. We didn't actually graph them, but it showed how to graph them. So there are some circles on here. Do you see any of the circles? Well,
Is it number 4?
they,
The homework that we got on block day.
oh no, yeah. You have to open big ideas in the textbook, but it's not actually on the textbook. So circle is going to be like X like there.
Oh, just like.
Right, so there you found a circle. I think that's what you want. I think there's two.
Okay.
Did anybody else find a circle equation on here?
Oh, I found another one.
Yeah. I figured you found it.
Hold on. Is it number 9?
Number 9 is one of them. Yep.
Number 4.
Number 4 doesn't have a Number 4 has a quadratic and 2 times.
Number 9. Number 7.
Yeah. Have a great weekend.
Don't worry about it all.
Bye.
I do, but still.
It doesn't even make any sense. That's what she said.
That's what she said.
Martin, you can't be
Base or something. Yeah.